Welcome back to the Deep Dive. We're your shortcut to getting smart about the big, complex topics changing our world. And today, we're really diving into something critical, artificial intelligence. Specifically, how AI models actually get used in the real world, how they're integrated, governed, managed, audited. Think of this as your personal tour through the essential Q&A, the stuff you really need to know about enterprise AI.
Exactly, and we're pulling everything straight from the source materials provided. The goal here is to give you that practical, structured view of AI from an enterprise perspective. We'll be dissecting, key areas like AI governance, risk management, how data operations work, and those really crucial auditing techniques. We want you to understand not just what these things are, but why. Why they're absolutely fundamental for deploying AI successfully and, importantly, ethically.
Okay, great. Let's unpack this then. We're essentially going to walk through these questions, answers, and explanations one by one, make sure we pull out all the key lessons. So let's jump right into our first section, AI models, considerations, and requirements. First question up. What is the primary goal of integrating an artificial intelligence AI model with a software system?
Yeah.
The options given were A, enhancing learning capability, B, securing training data, C, reducing computational resources, or D, facilitating better user interaction and application.
And the right answer, the main goal here is D, facilitating better user interaction and application. The core reason, well, it's pretty intuitive, actually. An AI model, doesn't matter how powerful it is, how much data it crunched, if it can't interact with the world, it's basically kind of useless in a practical sense.
Right, like having this amazing engine, super powerful, but no car around it, no way to actually use it.
Exactly. Integration is what gives the AI model, hands and feet.
Huh.
It lets users put information in and get insights out in a way that makes sense to them. It's all about accessibility and usability. Think about, say, a recommendation engine on a shopping site. The AI might be brilliant at figuring out what you like, but if it's not integrated into the website to actually show you those recommendations, it's doing nothing for the user. So yeah, enhancing learning, A, happens during training. Securing data, B, is always crucial, always, but it's not the main integration goal. And reducing resource needs, C, that's a design consideration, absolutely, but it's not the why of integration. The primary goal is making it usable.
Okay, that makes sense. Let's broaden the view now. Next question. Which of the following is the biggest advantage of using an artificial intelligence AI framework within an enterprise? Choices were A, faster AI adoption to boost revenue, B, maintaining human-in-the-loop efforts, C, ensuring AI initiatives align with organizational goals and values, or D, helping AI solutions increase customer satisfaction.
The biggest advantage here, the real strategic benefit, is C, ensuring AI initiatives align with organizational goals and values. You should think of an AI framework as more than just rules. It's like a strategic blueprint for how the entire organization approaches AI. It provides guidance, structure.
So it's about making sure every AI project isn't just some cool tech experiment, but actually pushes the company towards its main objectives,
Right.
pulls in the same direction.
Exactly that. Without that kind of strategic alignment, AI projects can easily become these isolated little islands. They might be inefficient or worse, actually run counter to where the business needs to go. Imagine, pouring resources into an AI for customer service when the company's real strategic pivot is towards, say, enterprise software.
Right, you'd be optimizing the wrong thing entirely.
Precisely. A good framework ensures that AI initiatives, from day one, support the core business strategy and ethical principles. Now, things like increasing revenue, A, keeping humans in the loop, B, or boosting customer satisfaction, D, those are all great outcomes, desirable results for sure, but they flow from a well-aligned strategy. The framework itself is what enables that crucial alignment in the first place.
Okay, makes sense. Now let's talk risks. The flip side, what is the primary risk associated with using deep learning DL models in business-critical applications? Options were A, inability to explain the decision-making process, B, high implementation cost, C, time needed for data preprocessing, or D, limited scalability.
The primary risk, and it's a big one, especially with deep learning, is A, inability to explain the decision-making process. Deep learning models particularly often operate as these black boxes. Their internal workings can be incredibly complex, almost opaque. It's often extremely difficult, sometimes impossible, to trace back why the model made a specific decision.
So if a deep learning model, say, denies someone a loan application, it might just say no, and we literally can't figure out the exact reason why. That sounds risky.
It is hugely risky, especially in critical applications, finance, healthcare, legal stuff, even self-driving cars. Understanding the why behind an AI's decision isn't just nice to have, it's fundamental. It's about accountability, it's about compliance, it's about building trust. If an AI impacts someone's life significantly, you have to be able to explain it. That's where things like interpretability and explainability, often called XAI, come in, trying to shine a light inside that black box. Now, cost B, data prep time, C, scalability issues, D, those are all real challenges, definitely. But they're often operational or technical hurdles you can tackle with resources or engineering. The lack of explainability, though, that hits right at trust, regulations, and the ability to audit critical decisions. It's a foundational risk.
Got it. Let's shift to data now, the fuel for all this AI. Next up, which of the following best mitigates the effects of using outdated data in the training of artificial intelligence, AI models? Options. A. Integrating new information retrieval techniques. B. Increasing the use of past data. C. Strengthening data access security. Or D. Ensuring high-quality data in datasets.
The best approach here is A, integrating new information retrieval techniques. The logic is pretty straightforward. An AI model is only as good as its data, right? And if that data gets old, stale, the model's performance just degrades, it drifts. We call that model drift, actually.
Okay. So it's not enough to have good data once.
Yeah.
The AI needs a constant stream of fresh information to stay relevant, almost like it needs to keep learning about the current world. That's a great way to put it. Continuously integrating new, relevant information keeps the model updated, keeps it tuned to reality. It actively fights that degradation from outdated data. This might mean setting up pipelines for continuous retraining, maybe using online learning where the model adapts on the fly as new data comes in. Now, ensuring high-quality data, D, is absolutely baseline, foundational. But quality alone doesn't solve the outdated problem. Strengthening security, C, protects data, doesn't update it. And using more old data, B, that actually makes the problem worse, right? You're reinforcing the outdated view. So yeah, continuous inflow of current info is key. Okay, let's solidify a core concept here, a really basic but vital distinction in AI. What is the primary difference between supervised and unsupervised learning in artificial intelligence AI models? Options were A, supervised uses random guessing, unsupervised needs labeled data. B, supervised labels data after predicting, unsupervised categorizes pre-labeled inputs. C, supervised uses unlabeled examples, unsupervised uses labeled sets. Or D, supervised learning uses labeled data and unsupervised learning operates on unlabeled data.
The primary difference, the absolute core distinction, is D. Supervised learning uses labeled data. Unsupervised learning operates on unlabeled data. Let's use an analogy. Think of supervised learning like learning with a teacher who gives you an answer key. You feed the AI examples where you already know the correct answer, the label, like showing it pictures labeled cat or dog. It learns to map the input, the picture, to the known output, the label.
Okay, so supervised learning is like learning by example with clear answers provided for each example.
Exactly. Unsupervised learning, on the other hand, it's more like giving the AI a giant, messy pile of data with no labels, no answer key, and asking it to find patterns or structure on its own. Like find hidden groups, cluster similar things together. An example is customer segmentation. You give it all your customer data, purchases, clicks, whatever, and it might group customers into segments based on similar behaviors without you telling it beforehand what those segments should be. It discovers the structure. The other options, A, B, and C, they get the definitions mixed up or just plain wrong. D nails the core difference.
All right, let's level up a bit. Generative adversarial networks, or GANs. How do generative adversarial networks, JNNs, enhance their ability to create realistic data? Options. A, training components simultaneously to improve authenticity. B, adding more layers to the neural architecture. C, employing grouping methods to classify data. Or D, leveraging trial-based learning for iterative rewards.
The really clever way JANs get so good at creating realistic data is A, training components simultaneously to improve authenticity. It's this competitive dynamic at the heart of JANs. A JAN actually has two parts, two neural networks, a generator and a discriminator, and they're trained together, pitted against each other.
So it's like they're in this constant digital arms race, one AI trying to through the other, pushing both to get better.
That's a perfect description. The generator's job is to create fake data images, text, whatever, that looks as real as possible. The discriminator's job is to tell the difference between the real stuff and the fake stuff the generator churns out. As they train together, side by side, the generator gets better and better at making fakes to fool the discriminator, and the discriminator gets better and better at spotting those fakes. This constant back and forth, this adversarial process, forces the generator to produce incredibly realistic, really authentic-looking data. Think about those ultra-realistic AI faces or deepfakes that's often GANs in action. Adding more layers, B, can make networks more complex, sure, but it's not the adversarial magic of GANs. Grouping C is classification, not generation. And trial-based learning, D, is more like reinforcement learning, a different paradigm.
Okay, shifting gears now. We're moving into a really vital area: AI governance and program management. It's one thing to build AI, but making sure it works effectively, ethically, and actually helps the organization and its people. That's often the bigger challenge. It's like, you've built this incredibly fast car, but now you need the rules of the road, the driver training, the maintenance schedule.
That's a great analogy. Governance provides exactly that structure.
So let's start with people. Our first question here looks at employee attitudes. Which of the following approaches would most likely improve employees' attitudes toward embracing artificial intelligence, AI, in an enterprise? The options were A, developing strong AI policies and ethical standards; B, training technical staff on model development; C, conducting enterprise-wide training and assigning department champions; or D, referencing AI frameworks and ensuring audits.
Right. When it comes to actually getting employees on board, feeling positive about AI, the most effective approach is C, conducting enterprise-wide training on the AI program and assigning department-level champions. Look, when AI comes into a company, it's natural for people to feel a bit apprehensive. Maybe worried about their jobs, maybe just confused about how it's going to change their day-to-day work.
Yeah, that makes sense. It's hitting those human concerns head on, right? Building understanding and trust, not just dropping new tech on them.
Exactly. This approach fosters open communication. That's absolutely key. Enterprise-wide training helps everyone understand the why behind the AI, the benefits, and importantly, how it's meant to help them, maybe augment their roles, not just replace them. And having those department champions, that's huge. Having someone relatable, someone you know in your own team who can answer questions, bust myths, be an advocate that builds trust from the ground up. It creates a culture of AI readiness. Now, policies, A, technical training, B, frameworks and audits, D, they're all important pieces of the puzzle, absolutely. But they don't directly address the communication and, frankly, the emotional side of adoption like broad training and internal champions do.
Building right on that human element, the next question asks, when we bring AI into the picture, what's a key reason for integrating workforce analysis? Options: A, to figure out the financial impact department by department; B, to navigate changes in roles and upskill employees; C, to help with higher-level decision-making; or D, to make sure departments follow guidelines.
The key reason, the really strategic driver here, is B, to navigate changes in roles and upskill employees. AI isn't just plugging in a new machine. It changes how people work, what skills are valuable. Workforce analysis lets the company be proactive about that impact.
So it's not just letting AI happen to the workforce, but actively planning for it, figuring out how roles change and getting people ready for that future state.
That's exactly it. It helps you see, okay, how will existing jobs evolve? What new skills will people need because of this AI tool? Where are the gaps? And crucially, it helps identify opportunities to retrain or upskill employees. You ensure your people remain valuable assets equipped for the future. Maybe AI automates data entry. Workforce analysis helps figure out who did that and what new, maybe higher value tasks like data analysis or AI oversight they can be trained for. Financial impact, A. Decision-making, C. Guideline adherence, D. They're relevant, sure. But workforce analysis is fundamentally about that proactive, people-focused planning for the AI transition.
Okay, let's talk accountability. Auditing. How can an IAS auditor best evaluate the overall effectiveness of the AI development lifecycle during an audit of an AI program? Choices: A, coding standards used; B, return on investment ROI calculations; C, metrics developed for the program; or D, AI awareness program evaluations.
The best way for an auditor to get a handle on the overall effectiveness is through C metrics developed for the program. Program metrics give you those quantifiable data points. They let you continuously monitor and evaluate how the AI solutions are actually performing. This isn't just about technical accuracy, though that's part of it. It's also about operational efficiency, whether it's sticking to ethical standards, how it fits into risk management.
Got it. So it's like the AI program needs its own dashboard showing all the vital signs: performance, efficiency, compliance, not just one single number.
That's a perfect analogy, a dashboard view. Coding standards. A. Important for quality, sure, but just one piece. ROI. B. Essential for the business case, but doesn't cover the whole governance picture, performance, ethics, operations. And evaluating the awareness program, D. That tells you if the training worked, which is good for adoption, but not about the AI's operational effectiveness itself. Metrics provide that continuous, measurable feedback across the whole life cycle.
All right, let's look at the strategic level, the steering committee. When developing an overall AI strategy, what should be the primary focus of the AI steering committee? Options were A, authorize budgets, B, oversee development and deployment, C, review technical details, or D, provide insight on newly identified risk and opportunities.
The primary focus, where that committee really adds the most strategic value, should be D. Provide insight on newly identified risk and opportunities. The AI steering committee, they operate at that high strategic altitude. Their core job isn't getting lost in the weeds of daily operations or deep technical specs. Their value comes from evaluating and prioritizing the big picture opportunities AI offers, and just as importantly, identifying and assessing the major risks. This high-level insight shapes the whole AI strategy.
So they're the strategic compass for AI, setting the long-term direction, looking over the horizon, not micromanaging the journey itself.
Exactly. Budget approvals, A. Important, but usually handled by finance, guided by the committee's strategic direction. Overseeing development, B, or reviewing tech details, C. Those are crucial operational tasks, but typically delegated to IT or dedicated AI teams. The steering committee's unique role is that forward-looking perspective, spotting emerging threats, seeing potential strategic advantages, and making sure the AI roadmap aligns tightly with the company's overall vision.
Next question hits a really crucial area, ethics. How can an organization best ensure ethical considerations are adequately addressed in its artificial intelligence AI strategy? Your choices. A, assign department managers to oversee compliance. B, create specific KPIs for ethical concerns. C, establish a specific AI ethics and compliance committee with stakeholders from relevant departments. Or D, contract external specialists for compliance oversight.
The best, most robust way to tackle this is C, establishing a specific artificial intelligence AI ethics and compliance committee that includes stakeholders from relevant business departments. Ethical issues in AI, they're rarely simple, they're complex, multifaceted. They touch on legal stuff, technical capabilities, business impacts, even broader societal norms. You really need diverse perspectives.
Right, so you can't just have one person or one department handle it. You need a dedicated group, like a brain trust, with different expertise weighing in. Legal, tech, business.
Absolutely. A dedicated committee pulling people from legal, tech, business, HR, maybe even external ethicists provides that structured way to identify, oversee, and proactively address ethical risks and regulatory duties. It ensures ethical implications are considered systematically, holistically, across the whole AI lifecycle. Just assigning it to department managers, A, risks fragmentation. Ethical KPIs, B, are good for measuring, but not enough on their own for proactive identification. And while external specialists, D, can offer great advice, relying only on them might weaken internal accountability and alignment with the company's specific culture and values. That internal multi-stakeholder committee is key.
Following right on that, let's talk about monitoring. What is the most important reason to implement model output monitoring for auditing artificial intelligence, AI systems? Options. A, to ensure new models function as expected. B, to automatically identify and correct errors. C, to reduce the need for human oversight. Or D, to identify and address potential biases not flagged by standard error reports.
The most important reason, and this is really critical, is D, to identify and address potential biases that may not be flagged by standard error reports. Now, ensuring new models work, A, is important, sure, but monitoring isn't just for new models. Bias can creep in over time, even in established systems, as data changes or the world evolves.
So bias isn't just a one-time check at the start. It can sort of subtly emerge later, almost invisibly if you're not actively looking for it in the outputs.
Exactly. It can be insidious. Standard error reports are good at catching obvious technical glitches or big performance drops, but they often miss those more subtle systemic biases or unfair patterns in the AI's outputs. These biases, if they go unchecked, can lead to really harmful outcomes, discrimination in hiring, unfair loan decisions, you name it. Model output monitoring, which often involves human review and specialized fairness checks, helps uncover these hidden biases that automated error reports might miss entirely. It highlights where human judgment and intervention are still needed.
Stepping back a bit, let's summarize governance. What is a key outcome of implementing governance practices for artificial intelligence AI systems? Your options. A, faster deployment timelines. B, more complex algorithms. C, consolidating governance to tech groups, or D, ensuring AI systems align with organizational values and maintain compliance?
The key outcome, the real purpose of AI governance, is D. Effective governance ensures AI systems operate in accordance with organizational values while maintaining compliance. Governance isn't really about speeding things up. Sometimes careful planning might seem slower initially, though it pays off hugely long term.
It's not about making algorithms more complex just for complexity's sake.
Right, it's more about the guardrails and the accelerator, making sure the innovation stays on the right ethical and legal track. That's a perfect way to put it. And it's definitely not about handing all governance over to just the tech teams. C. As we said, effective governance needs that multidisciplinary approach. The real value of governance is providing those strategic guardrails. It ensures that as we chase the benefits of AI, we do it in a way that aligns with the company's mission, its values, and all the legal rules. It prevents unintended harm and builds trust.
Okay, last question for this section, nailing down responsibility. Which of the following is most likely responsible for ensuring that an artificial intelligence AI program adheres to ethical practices and regulations? Options: A, Chief Information Security Officer, CISO, B, IT Operations, C, Chief Executive Officer, CEO, or D, Steering Committee.
The entity most likely responsible for that overall adherence is D, the steering committee. While the CISO is vital for security, IT Ops B handle implementation, and the CEOC has ultimate accountability, the AI Steering Committee is specifically set up for that holistic strategic oversight of the AI program.
Right, this ties back directly to what we were saying earlier about their strategic role, overseeing the big picture alignment.
Exactly, it reinforces that. The steering committee sets the overall direction, including the ethical and legal standards. They're responsible for ensuring that direction is followed across the whole enterprise. They're the designated oversight body for ensuring the program sticks to the strategic, ethical, and regulatory plan.
All right, let's move on now to AI risk management. This is such a critical area, often where AI initiatives succeed or, frankly, fail. Let's kick off with a common problem: skill gaps. Which of the following would best address a gap in properly skilled employees when forming an artificial intelligence AI strategy? Options: A, engage external experts. B, restrict AI to existing capabilities. C, prioritize training existing staff. Or D, defer strategy formation.
Okay, so when you're right at that crucial stage of forming the strategy, the best way to plug an immediate skill gap is A, engage external experts to provide guidance. Now, prioritizing training for your own people, C, is absolutely vital for the long run, no question. Building that internal muscle is key. But it takes time, often more time than you have when you need to get the initial strategy right.
Right, so this is about getting expert help quickly to set the right direction from the start, rather than delaying everything while you wait for internal skills to develop.
Exactly. Consultants or external experts can bring that specialized knowledge immediately. They can help build frameworks, guide the initial planning, maybe even help set up early projects. That accelerates the whole process. Just restricting yourself to what you can do now, B, is too limiting. And deferring the strategy, D. In this fast-moving AI world, that's a recipe for falling behind. So for that initial strategic lift, external expertise is often the quickest, most effective bridge.
Let's switch to security risks again. Adversarial attacks. What is the primary security risk posed by adversarial attacks on machine learning (ML) models? Choices: A, stealing the model's architecture. B, overfitting the model. C, manipulating input data to deceive the model. Or D, increasing training cost.
The primary security risk here, and it's a really nasty one, is C, manipulating input data to deceive the model into making incorrect predictions. Adversarial attacks, they're sophisticated. They involve making these tiny, often invisible changes to the input data, changes specifically designed to fool the AI model, to trick it into making a wrong, maybe even dangerous decision.
Wow. So like that example of a tiny sticker on a stop sign making a self-driving car misidentify it. That sounds incredibly dangerous in the real world.
That's a perfect, chilling example. Or imagine a fraud detection system missing an obvious scam because the input data was subtly tweaked to bypass its checks. The core issue is that these attacks directly undermine the integrity and reliability of the AI's decisions when it matters most out in the real world. Now, stealing the model A is an IP risk. Overfitting B and training costs D are performance and efficiency issues. But adversarial attacks uniquely target the trustworthiness of the AI's output in real time.
Okay, ethics again, but this time right at the beginning, in planning. How can we best ensure ethical considerations are included in the planning and design phases of the artificial intelligence AI lifecycle?
Yes.
A, reviewing the business case. B, ensuring legal team involvement. C, performing a preliminary risk assessment, or D, using only supervised learning models?
To really bake ethics in early, the best approach is C, performing a preliminary risk assessment. This is fundamentally about being proactive. A good preliminary risk assessment shouldn't just look at technical or financial risks. It needs to explicitly consider the ethical and human rights impacts too.
Got it. So you're designing for ethics right from the start, building it into the foundation, not trying to slap it on as an afterthought later when problems emerge.
Exactly. It's far easier, far cheaper, and far more effective to identify and address potential ethical issues during planning and design. You can build in safeguards from day one, discovering a major ethical flaw after deployment. That's expensive, damaging to trust, and much harder to fix. Reviewing the business case, A, might touch on some aspects, but maybe not deep ethical nuances. Legal involvement, B, is crucial, but often focused on regulatory compliance once risks are flagged. And just using supervised models, B, that doesn't guarantee ethical outcomes. That early, broad risk assessment is the best net for catching ethical concerns up front.
Okay, many companies use third-party AI. So what approach most effectively reduces risk associated with using them? Options. A, transferring AI risk to the vendor. B, ensuring clear service level agreements, SLAs. C, sharing internal privacy policies. Or D, establishing a shared responsibility model.
The most effective approach here is D, establishing a shared responsibility model. And the key thing to understand is you can't just transfer all the risk to a vendor. Ultimately, the organization using the AI often retains significant accountability, especially for how it's used and the data involved.
Right. So it's not about just handing off the problem,
Yeah,
but clearly defining who's responsible for which piece of the risk puzzle.
precisely. A shared responsibility model explicitly outlines who does what. The vendor might be responsible for the core model security, the infrastructure it runs on, but the client organization, they're likely responsible for the data they put in, how they use the outputs, ensuring it meets their specific compliance needs. Think like cloud security, the provider secures the cloud itself, the customer secures what they do in the cloud. That clarity minimizes gaps, misunderstandings, and liability. Clear SLAs, B, and sharing policies are important parts of managing vendors, sure, but they fit within that broader shared responsibility framework.
Okay, model drift, again, that concept keeps coming up. What is the primary concern related to model drift in an artificial intelligence AI solution? Options. A, highly regulated access to new training data. B, model performance degrading over time due to changing data relationships. C, model performance staying consistent while usage increases. Or D, expanding data scope needing more privacy controls. The primary concern, the very definition of model drift's impact, is B. The quality of a machine learning ML model's performance can degrade over time due to changes in data relationships within the system. Remember, AI learns from history. But the world changes, right? Customer behavior shifts, markets fluctuate, new trends pop up. The patterns the AI learned initially might just not hold true anymore. The outdated map analogy again. The map was right when printed, but the roads changed, making it less useful, even dangerous over time.
That's exactly it. The model becomes out of sync with reality. Its performance drops, predictions get less accurate, decisions might become unreliable or even biased based on old patterns. This isn't about bugs in the code. It's about the model's knowledge becoming obsolete relative to the current environment. Data access regulations, A, and expanding scope, D, are related governance issues, but not the drift itself. And C is the opposite of drift. The core concern is that performance decay.
Okay, final one for this risk section. Sometimes risk is unavoidable.
Yeah.
What is the best course of action for an organization when artificial intelligence AI-related risk exceeds acceptable levels but remains unavoidable? Options. A, modify the AI system to manage the risk. B, stop using AI altogether. C, delegate management to a third party. Or D, monitor the risk actively to manage potential escalations.
Right. When you have a risk you just can't eliminate and it's above your normal comfort level, the best course is D. Monitor the risk actively to manage potential escalations. With cutting-edge tech like AI, some risks are just inherent. You can't engineer them away completely. So if you can't prevent it, you prepare for it. The focus shifts to vigilance and readiness.
Okay, so if you can't stop the volcano from potentially erupting, you install sensors, monitor it constantly, and have clear evacuation plans ready to go.
Precisely. Proactive, continuous monitoring lets you see if the risk level is changing, if it's escalating towards a potential incident. You set clear thresholds, triggers for action, and have response plans rehearsed and ready. Modifying the system A is ideal as possible, but might not be feasible for truly unavoidable risks. Stopping AI use, B, is drastic, losing all the benefits. Delegating C doesn't eliminate the risk, you still need oversight. Active monitoring allows you to manage that residual risk intelligently.
Wow. Okay, that really was a deep dive into the nuts and bolts of integrating, governing, managing, and dealing with the risks of AI. We covered a lot from basic model integration right through to complex governance and unavoidable risks.
We really did. Key themes that kept popping up were, the need for strategic alignment, using frameworks, managing risks proactively, the absolute criticality of data quality and keeping it current, and that vital human-centric approach both for adoption and for ongoing oversight. And these aren't just tech issues, are they? They're fundamental business strategy
Yeah,
points.
absolutely. So as we wrap up, what really stood out to you listening today, and maybe chew on this, in this incredibly fast-moving AI world, how do companies find that balance between pushing innovation, moving fast, but also maintaining that robust governance, ethical oversight, and transparency we've talked so much about?
Indeed. That's the tightrope walk, isn't it? It's not just about building AI anymore, it's about building trustworthy AI. And that demands continuous learning, constantly adapting, which hopefully is exactly what we helped you do a bit of today.
Well said. Thank you so much for joining us on the deep dive. Keep exploring, keep questioning these important topics. We'll catch you next time.